What I think we learned really early on in the development process was the truth was going to be scary.
It's overwhelming now how easily germs are spread and how easily one can contract these viruses.
Once the severity of the outbreak becomes clear, social structures start to deteriorate, and we kind of turn into barbarians. The way we live our lives is so fragile, and so the movie explores, that fragility.
It made me start thinking about, are we prepared?
Where's the fire department?
In a society where we rely so heavily on the infrastructure of the society, the answer is no. We would all probably be in quite a bit of trouble.
The overriding impression I got from all of the experts on this was that it was a matter of when, not if.
You're imagining when I get sick, there's pills or there's a vaccine or something, or even if there's not, my president can protect me. What I think everybody has to understand is that that comfort zone is false.
I think all of us, when we get sick and we get the flu, wonder what's going on in our bodies. And viruses are amazing because they don't behave the way other living things do. They sort of inhabit a cell and then reprogram the cell and use it as a Xerox machine and make copies of themselves and then proliferate throughout your body. And if your body has seen this virus before, it can deal with it. If your body hasn't, it's got to figure out with its antibodies how to combat this thing.
We think of evolution for ourselves as occurring over millions of years. For these guys, evolution's occurring on minutes and hours, and these things are constantly changing, and so they pick up a nasty gene. If they have that capacity to spread, now you're talking about something that's really dangerous.
With the new mutation, we are predicting an R0 of 4. Approximately 1 in 12 people on the planet will contract the disease.
Could something emerge that had this extraordinary capacity to both spread and kill people? And could it paralyze economic systems and the capacities of government? Yes, all of this could happen.
So we have a novel virus with a mortality rate in the low 20s, no treatment protocol, and no vaccine at this time.
That is correct.
We live in a scary world where environmentally we're encroaching on animals' habitats, they're encroaching on ours, we're cutting things down that we shouldn't be cutting down. Things are changing, and viruses are coming out of those zoonotic events where man interacts with animals.
60% of the illnesses, the infectious diseases that a human being could encounter in their life come from sort of the animal kingdom that jump into the human species.
Maybe an isolated Homo sapien here and there was exposed to these viruses in the past, but it never had the opportunity to take off the way it does now in our globalized and urbanized world.
Trains, planes, everything goes faster. So a virus will go faster as well. When a virus spreads, the world becomes very small.
There will be more and more of these viruses that are entering, and there will be devastating viruses that occur in all of our lifetimes. And the real question, and how sort of future generations will judge us, is to what extent we were prepared for it. We need to get ahead of the curve. We need to be approaching these things, and we need to be thinking about how are we going to go out there and predict the occurrence of these pandemics, and how are we going to prevent them. Each day in the world, animal populations die from infectious diseases. Sometimes the deaths of animals can precede humans. Part of the objective is to actually find these events and catch them.
Somewhere in the world, the wrong pig met up with the wrong bat.
If a vaccine or effective drug was discovered, the demand would be there, but have we really thought through what it would take to immunize an entire population of a city in a short period of time? That's the kind of things we really can't start thinking about.
I'm hoping that this movie will stimulate a conversation about what does preparedness mean, what are the investments that it takes, what are we willing to do to make the world safe for our children from the increasing risks of pandemics.
We have a responsibility to take care of this earth that we share because ultimately, it is the only home that we're gonna have. And I think we don't wanna wait till it bites back.
As of last night, there were 5 deaths and 32 cases.
If there's an outbreak somewhere, and this is what both the World Health Organization and the CDC do, samples come in to select labs.
We send samples to the CDC.
In 72 hours, we'll know what it is.
Their job is to look at these samples and try and figure out what the hell happened.
We tested all of our antibodies. I didn't see much cross-reactivity.
We went to the CDC and we saw the samples that are locked away in the BSL-4 labs where you need to have a retinal scan to get in there because this stuff is so lethal.
When you have no idea how a virus is transferred from one person to another, you have no idea how it travels, you don't know how it grows, you don't know what it attaches onto, you don't know any of that, and you're really in the dark, you go to a BSL-4.
It's the highest level biosafety lab there is, and this is where they really study the dangerous stuff.
From here on out, I want no one working on this except the BSL-4.
So the actors had to learn how to wear the suits, what the safety procedures were. We had somebody from UCLA, Natasha Griffith. She was instrumental in helping getting those procedures correct.
Just pull the cassette out very gently, because otherwise everything is going to start falling out, because adhesive doesn't hold inside.
Okay. That's good to know.
Jennifer Ely spent a lot of time in the labs to understand what it's like to be a scientist.
I spent an afternoon with Natasha and Dimitri, actually in the suits, in the mock-up lab, getting used to them, and even attaching and detaching the air hoses is quite tricky, and we wanted it to look like we were as au fait with it as possible. Well, the suit is filled with air that is constantly being pushed out so that nothing can travel in to the environment inside the suit to create a barrier, and that is also the air that you breathe.
We had the real suits that had to be custom made because you can't just throw on any size. They're specifically, for your sizes. They make them brightly colored because you want to know where your suit is, because if you tear it for some reason, you're toast. So we had to make all that function and work with a lot of technical adventures.
We tried using dead virus combined with several adjuvants to boost immune response.
And?
No protective antibodies, a lot of dead monkeys.
Many of the figures that we use in the film are based on scientific data, the growth of the virus in tissue culture, the ways in which people would make vaccines. All of these things are really based in current status of knowledge.
Are we even close?
If we even had a viable vaccine right now, we would still have to do human trials, and that would take weeks.
I asked both Natasha and Ian if they would inject themselves to test a vaccine in this situation, and they both answered without hesitation that they would do so. It's their purpose is to deal with these emergency situations, and if that's what they need to do in order to do that, then they will do it.
I hope that people come away realizing what these scientists do, and how hard they work and how kind of amazing their jobs are.
I'd rather the news story be that we overreacted and that many people lost their lives because we didn't do enough. That's why we're here today.
There are some people whose job it is to protect and look forward about where this thing is going to go and how big it's going to be, and should we be closing schools and shutting down airports, which of course have huge economic implications. That's sort of the world that Lawrence Fishburne's character has to preside over, is how do you build policy in the face of that kind of panic?
And the affected cities are Minneapolis, Chicago, Los Angeles, Boston, and Salt Lake. He's the guy that you look to who's going to tell you that everything is going to be fine. We are going to figure out what it is. We are going to contain it.
We've reached out to the WHO, see what they know. The WHO has a community of people called GORN, the Global Outbreak Response Network. CDC has the GDD, Global Disease Division. The way in which we communicate the threat, respond to the threat, keep track of how we're doing, those are the tools of trade that epidemiologists have used in combating every disease.
How much information do you release to the public? How much are they entitled to know? How much should you tell them? What should you hold back? The pressure and responsibility is intense.
People will panic. The virus will be the least of our worries. It will tip over now.
The idea of letting people know about potential problems, I think, is one of the most difficult issues that medical reporters deal with. A person wants to know when they hear something bad or something scary, what does that mean for me? What does that mean for my family? And I think you have to be ready with those answers as soon as you are starting to deliver this news.
Tell them what an Arnold of 2 really means, Dr. Cheever. Teach them some math, No?
What we're not so good at is coping with the fear and how we communicate about the virus and how the internet and other kinds of media can be used to create a different kind of pandemic.
They say the French and Americans have a cure.
Who says?
The internet.
And you believe it?
In a sense, those misconceptions and the fear that they breed are also a kind of virus that I wanted to write about.
In order to get scared, all you have to do is come in contact with a rumor. I think what Mr. Crumwoody is spreading is far more dangerous than the disease.
There's disinformation about everything because we live in an era where the internet can be updated, so you can write anything about anybody. The damage is irreparable because it creates panic.
This is for Scythia. If I'm here tomorrow, you'll know it works. It's interesting to think about the information almost as a transmissible disease. I mean, it can cause a lot of damage, and it spreads very, very quickly, and in some cases, people can actually suffer or die from it. I think his demand for all the truth is really interesting, and perhaps something that governments in this situation should think about. How do you feel about surrendering your rights today by getting this vaccine? What if there's a side effect to this vaccine? I think his demands for alternatives is interesting and something that we should demand and expect in scenarios like this. You know, give us alternatives.
There is no proof that Forsythia works.
What defines works? Against what strain of the virus? I don't think anyone will say that we're going to live in a world that's free of infectious diseases. So instead of focusing on that, let's focus on ways to make sure that if one happens, if there's an outbreak, that we can mitigate the damage as quickly as possible.
We're isolating the sick and quarantining those who we believe were exposed.
The great thing about Contagion is that we really get to portray the scientists and the researchers as the heroes that they really are.
These individuals, these medical professionals, they are sent out when there has been an unexpected outbreak of a new virus, and their job is to find the pathogen of that virus.
It was very interesting to talk about how they personally react to such scary situation. They are trained not to panic.
It's basically like being a Sherlock Holmes of the medical field, and it's been absolutely fascinating learning a little bit about that world.
Well, these EIS officers and World Health Organization officials are detectives. They're medical detectives. Doctors like Ian Lipkin and Larry Brilliant, who are advisors, and journalists like Laurie Garrett. They really are out there letting the people know what's going on.
Both Ian and Larry felt like the movie had an opportunity to get the truth out about the reality of this situation.
It was a real sense of security, like a security blanket, you know, to know that they kind of had our back on the set to make sure that everything we were doing, we were keeping as real as possible.
We even knew our Nautilus. It's not two anymore.
Most movies that are done about epidemics or pandemics, they usually don't pass the sniff test for epidemiologists. I think in this movie, the science is really good.
I can see some structures on the surface that look like glycoproteins, but there's nothing morphologically pathognomonic.
I think the most important thing in the story, even more than the virus itself, was to accurately portray how the people involved in disease investigations and public health do their jobs.
I want 25 rows, 10 beds apiece, the most febrile cases at this end.
You could listen to Kate Winslet asking questions about how should I feel? Am I happy that I put my life at risk? Is it worth it? I mean, it was fantastic.
I don't want to be the movie version of an EIS officer. I want to be an EIS officer. Every single EIS officer that I met just said, your hair, you just don't even do your hair. You wash your face, you brush your teeth, you go, you barely look in the mirror.
Kate wanted to know some of the experience of being on an actual outbreak, but also things like how much money does an EIS officer make?
It just tells you a lot about a person, whether or not she had a car, whether or not she had a partner or a family. They have to come from somewhere. You have to feel that that is a real person. You know, you have to be a pretty tough, brave individual to be able to do that.
I need you to clear his floor, right now.
It helps set a foundation for an actor to be able to handle items in a real way. Actors are always looking for ways to learn more about their world. In this case, medical world and the military world of the CDC.
We spent a lot of time working with the actors and trying to explain to them the organizational chart and how people do field work and so forth.
Their understanding of a subject so thoroughly that they can put it into very clear layman terms. I feel like I've learned an enormous amount.
If R0 is 2 and it doubles every 4 days, it's the 1918 pandemic all over again.
A few of the actors came through our lab and they spent some time learning how to work in a laboratory, learning how to extract genetic material, look through a microscope.
I was really fortunate to get a chance to spend 2 mornings with Ian Lipkin and his team, to get a chance to be led through the baby steps of some experiments and finding DNA sequences, and it was really exciting. I've learned a lot.
The actors had to learn how to wear the suits, what the safety procedures were. They were great. We had somebody from UCLA, Natasha Griffith. She was instrumental in helping getting those procedures correct.
You know, the lengths that one has to go to in order to protect oneself, you know, they are fairly extreme. So we've had a lot of wearing of Tyvek suits and masks and so on and so forth, and, you know, double gloves with duct tape wrapped around the wrists and etc.
They had me do experiments and they talked me through them and told me what to do, and I was very interested to see, of course, the way that they did it, how at ease they are with their tools and the things they use to do their job.
Cook your samples, destroy everything.
We're making progress. I can do this. If we can convey the feeling that we are as passionate about the roles we're playing as the actual people are, that's the key to this being successful.
Sorry I couldn't finish.
It's an extraordinary job that they do. It was fascinating and an honor to be around those people.
Marion and Kate and Fishburne's character all are basically trying to keep society afloat and the world alive. I mean, it's a pretty amazing job what these scientists do, you know, and how hard they work and how amazing and thrilling their jobs are.
This is an influenza virus. This is the world. How can a virus change the world? Here's how. A virus survives by jumping from one host to another and hijacking its cells for its own malevolent purposes. With each jump, the virus mutates slightly. Enough mutations and our little virus can jump to different species. Keep in mind that influenza tends to jump from birds and pigs to humans. So let's say the virus jumps into a human host. Worse, this iteration is capable of jumping from human to human. This first case is called the index patient. He unknowingly infects other people around him. Those people infect more people and so on until we have an epidemic. Now let's say that epidemic continues to spread unchecked across the planet, like Bieber fever, but deadlier. This is called a pandemic. What happens when a pandemic strikes? In 1918, the Spanish flu caused 50 million deaths. That's more casualties than World War I, which happened to be going on at the same time. P.S. It wasn't just the old and weak. It was the young and healthy that got it the worst. But it's not always so nasty. In 2003, SARS was curbed before it got out of hand. But let's say a full-on pandemic did happen. First, public gathering spaces are closed. The forever alone among us may not even notice it. Public transit and international travel slow or shut down entirely. But what if it keeps going? The good news is you'll probably be able to spend a lot more time in your favorite sweatpants. Governments declare states of emergency and quarantines are established. Common luxuries like food and water are getting tricky to locate, so we're all enjoying the fine dining experience of MREs eaten with oh-so-elegant sporks. Private business slows, which leads to a global recession on top of the pandemic. And we have to endure the inevitable terrible AIDS song recorded by the most obnoxious artists in contemporary popular music. But fear not, we can do plenty of little things to prevent this worst-case scenario. 1. Wash your hands often. Researchers estimate that if everybody washed their hands regularly, 1 million deaths could be prevented every year. 2. Get your flu vaccine every year. Health experts create new vaccines each year to counter new flu strains. 3. If you feel sick, stay away from people and see a doctor. If you've got influenza, you can infect people up to 6 feet away. 4. Develop an emergency plan and stock up on supplies. That way you're covered just in case. For more information, check out takepart.com/contagion.